Okay, let's graph this quadratic, or this fourth degree, this quartic equation. So the way to graph it is to first try to find the zeros, which means the x-intercepts. And if possible, the best way to do that is to factor your equation into a bunch of, basically a product of linear factors, if you can do that. So basically I'm saying, do you know how to factor this? So to factor it, you'll see that each one of these has an x squared in it. That's called the GCF, so let's take the GCF out. When I take x squared out, here, if I factor an x squared out of that, if I pull an x squared out, I'm left with x squared. Right? Here, I'm left with negative x, and here I'm left with negative 6. So that's the first step. And notice that if you multiply this back in, right there, and right there, you get this. Because factoring a GCF out is just like the reverse of distributing a monomial into a polynomial. Does that make sense? Distributing a monomial, one term, into more than one term. It's just called the distribution property, or multiplying and distributing, right? But now I need to try to factor it even more, because this is nice to have, but what about this? I don't know what the zeros are of that. That's like having a quadratic. Well, that, again, do I know how to factor? Well, now I'm going to factor the old-fashioned way, which means reverse foiling. So I take this x squared,
oh wait, yeah, I do know how to do
and I make it x and x, right? And then I take this negative 6, and I make it what? What two numbers multiply to negative 6 and add to negative 1? Negative 3 and positive 2. And you'll see now that if you FOIL this back out, that you'll get back to this. Now, why would you want it in that form? Why would you want it like x squared times x minus 3 times x plus 2? What's the value of having that? Well, now you know what your zeros are. You've got 0, and that's got multiplicity 2. So I'm going to just write it twice, right? Because there's really 2 of them there. You don't really have to count it twice, but it's important. You'll see in a second. There's 3, right? If I set that equal to 0 and solve it, I get 3. And right here, if I set that equal to 0 and solve it, I get negative 2. Which means up here, if I were to plug negative 2 in for x, and you can test it in your calculator to see, you'll get 0 as your answer. And if I plug 3 in for x, in all those, you'll get 0 as your answer. And if I plug 0 in for x, you'll get 0 for your answer, which is obvious. Okay, why do we want to know that? Well, now we're going to try to graph this. So here's my x, y axis. I have a 0 at 0, and it has multiplicity 2. We'll talk about that in a second. I've got a 0 at 3, and I have a 0 at negative 2. Now to finish my rough sketch of my graph, I want to find out basically what the end behavior is. So the end behavior has to do with the degree of the polynomial, and it also has to do with the leading coefficient, if it's positive or negative. So I've got a positive leading coefficient, and I have an even degree polynomial. So think of your most obvious even degree polynomial, right? X squared with a positive leading coefficient, 1x squared. What does it do? It goes up on the left, and it goes up on the right. So I'm going to go to my left and right, and I'm going to draw an arrows up, because I know that's what's got to happen. Now we go to the zeros and we look at the multiplicity. See how these ones are both multiplicity 1? That means, since it's odd multiplicity, that means it goes through at that point. So it's going to come through. And see how this is multiplicity 2? An even multiplicity. Multiplicity 2, that means it bounces off and it comes back. So it's going to do this. Now, I don't know how far below it goes, and your teacher doesn't care about that. I mean, you could plot a point if you wanted to. You could plot a couple of these points just to see, but you don't really need to do that. She just wants to see your zeros and your end behavior. So it's going to do something like this. And notice it bounced off of that 0 at x equals 0. It bounced off of that because of the multiplicity 2. And so that's the rough sketch of your graph.